Hey guys, so in this video we are going to talk about precision and accuracy. So these are two terms that we often use while measuring physical quantities. For example, we say it is precisely 2 kilograms or precisely 2 centimeters. The value that we have measured must be accurate. So what is the actual difference and the meaning of precision and accuracy? So that's what we are going to learn in this video. So let's start off by getting an example. Let's say I have a peanut weighing exactly 2 grams. So this 2 grams is called the true value of the physical quantity, which is the peanut in this case. So the 2 grams is the true value of the peanut. So true value means the actual measurement of the physical quantity. So let's say that there are two people who are measuring this peanut, and both the people are getting different values. So they are measuring the peanut multiple times, more than one times at least. So let's say person A measures the peanut in his first attempt and in his second attempt, right? So in his first attempt, person A got the value 1.99 grams, and in the second attempt he got the value 1.98 grams. And then person B got 1.95 grams and 1.94 grams. Then let's say another person A is also here, and he took the first value as 2.11 and 1.99. So let's see what the person A, B and C have measured, whether it is accurate or precise. Let us first define what accuracy and precision really is. So accuracy involves how close you come to the true value while measuring a physical quantity. So let's just first understand the definitions here, and then we'll go back to the example that we started with in the first. And now let's move on to precision. So precision tells us how close the measured values are to each other. So if you notice here, we are not in precision, we are not being told how close, or we are not being told anything about how close or how far the measured value is to the true value. We are just talking about how close they are to each other. So note these definitions down, and then let's go back to the example we started with. So now over here, let's take the case of person A. So person A has measured, his measured values are 1.99 and 1.98. Both of these values are very close to each other. They only differ by a number of 0.01. So this is the difference. This is the difference between both these values, 0.01. So we can say that both of these are precise because both the measured values are close to each other. That's what precision means, right? And then we can also say that both these measured values are very close to 2 grams, which is the true value of the peanut. So we can say that they only differ by 0.01 and 0.02. They are very small differences. So we can say that both of these values are also accurate, because accuracy only involves how close we come to the true value while measuring a physical quantity. So person A has both the values as precise and accurate. Now let's move on to the case of person B. In the case of person B, we can say that it is relatively less accurate because it differs by both of these differ by only 0.01. So these measured values are accurate because the difference between both of them is very less, 0.01. But the difference between the true value and what the measured values are, that is a bit more. That means it is relatively more than the first person. So we can say that the second person is precise and not accurate, but the first person was precise and accurate. Now let's move on to the case of the second person. Now the second person, let's make this value as 0. We can say that both of these values are relatively further from each other, right? So let's change this value to be 8 and this to be 2, so that I can better explain it to you guys. So we can see that both of these values are close to 2 grams, which is the true value of the peanut, but they are not that close to each other, right? Their difference will be 0.04, right? That's the difference between the measured values of what person C has measured the peanut for. And we can see that both these values are very close to the true value of the peanut. So we can say that the two measurements the person C has taken for the peanut is accurate but not precise. Okay, hope you guys understood. And now let's move on to some examples. So this is the first example, and I would like you guys to solve the example. And in this example, the true value of the physical quantity is 4 meters, and there are 3 people, and we need to find out who is accurate, who is precise, who is both accurate and precise, who is just accurate and not precise, like that, right? We need to find out what precision and accuracy really means. There are 3 experiments that, like the measurements that they have taken, and I'll give you 5 seconds to solve the problem. I mean, you can copy the problem down and solve it, and pause the video and solve the problem. I'll show the answers in 3, 2, 1, now. So here are the solutions. The person A is precise and not accurate. Person B is not precise, neither is he accurate, and person C is both precise and accurate. So you might wonder, when there are 3 values given, then how do you find precision and accuracy for one measurement? So we take the average of the 3 values, or how many ever values there is, and then we see whether it is close to the true value or not. By that we can say whether it is accurate or not. And precision just depends on how close these values are to each other. Since person A's values are close to each other and differ only by 0.1 or 0.01 and 0.02, that means he is precise but not accurate. And person B is neither precise nor accurate because the values differ by a lot. And in person C, the values don't differ by a lot, and on top of that, all the values are close to each other. So that's it for this video. I hope you guys have an amazing day.